regarding the Plotly and more web-based, web-ready graphic. I work in the healthcare industry, so the information that I usually deal with are very privacy sensitive.
Mm-hmm.
How secure is with Plotly and all these, and when I publish it, I only want certain people to see. So does it meet the, I guess, the industry standard in terms of securities or things of that nature?
If it's HIPAA, if you're dealing with kind of legal issues like HIPAA, I mean, I know with healthcare, um, people I've worked with, they're dealing with things like HIPAA rules, and it's actual, if it's if you're getting into like using that sort of data, um, and are you thinking in terms of like using that data for your final project?
Oh, no, no, I'm not using that for final project, but I'm just thinking in eventually at my work, I want to incorporate some of the things that I learned from this course and kind of create a dashboard for the executive team so they can see it daily or whenever they want and interactively. But I want it to be secure, so um, I don't want just anybody to be able to see it later
Mm-hmm,
on.
mm-hmm.
Yeah, definitely HIPAA information's involved, but I'm not for the final projects, but more for at work, the intended audience only.
Okay. So yeah, we could talk about that offline. So maybe send me an email, and I could talk to you a bit more about using that professionally. But just kind of um, just in terms of like relevance for the course, the you know the, like one of the requirements for the final project is that the data is able to be publicly posted. So that's something to keep in mind. That I mean, I encourage everyone to use their subject matter expertise for the final project. But if you're, I mean, if there are kind of data issues like that, just know that for the final project, it will be publicly posted. So that's one of the requirements.
Understood, yeah. Hmm.
And I guess yeah, we could talk offline um, about using something like Plotly professionally. Any other any other questions?
One quick question. Can you guide me to some of the material for big V's? I searched on net and I was not able to get no material around no examples or.
There's so in the video would be the best one of the best like first places to go to.
Right.
The I don't know, I don't remember offhand what I had a couple links prepared for there, and I'm not remembering offhand what they were. The the GitHub page, it's there is some documentation here, and there's I in the video I found another. I referenced another site, and I'm not remembering exactly what it is, um, but um,
Okay, I'll check that out then in that. Yep.
yeah, and it's a pretty quick video. It's just like 10 minutes, so it's not. I think this was the one. No, I think this might have been some. Yeah, so I'd have to search for that, but but it's in the video. The links that I was going through. It's yeah, and in terms of what for homework to what you guys will be using, something like BigViz, it's really meant for pre-processing of data. So the way that you could kind of think of BigViz is if you have a data set where you have, and that's what this Pluto data set is. It's a large data set, and you need to give some thought into how you want to visualize that sort of information. So one of the this is kind of an example of what could happen when you have a lot of data points. This is kind of just an example of like dealing with larger data sets in Plotly, but this is also kind of an example of the trouble that you run into with larger data sets. If you are trying to, if you have 100,000, a million data points, the question becomes like, what's the best way to really visualize something like this? This is obviously, this is just random data, but with the Pluto data, you'll be dealing with, similar issues where it's, you end up not getting much information with something like this. And so if you're just looking at a scatter plot, like you need to find another way to look at this. And in terms of like the main techniques to kind of working with this is binning is sort of binning data. So looking at something like this, the way that you could kind of imagine it is imagine if here we have kind of axis lines that we could use. So imagine if each one of these boxes, we ended up saying, let's count how many points we have in that box. So how many points do we have here? How many points do we have here? And looking at this data rather than looking at a scatter plot like this, looking at it as as what's called a heat map. So you're able to see like where do you have more points, where do you have fewer points, and that gives you more information than trying to find out are there more points here or here by looking at a scatter plot. And so with Big Viz, this is a way of kind of preparing your data for being visualized in this way. And in the video, I go through a couple of examples where it's you're essentially using bin and condense. So what this is doing is essentially you're able to set your bounds, or you're able to say like I want to I forget if it's you're dividing it into a number of bins, or if you're defining the length of the bin. I'm not remembering that off the top of my head, but basically you define, let's say you have a range of -5 to 5. You either define, you have 10 bins, and how do you want to like essentially this is a way of very quickly binning that data and getting essentially a set of 10 numbers where you have counts of how many points are there. And so looking at like a scatter plot, it's more two-dimensional, so that lends itself to things like heat maps and like mainly something like a heat map. But the even an even simpler example of binning is something like a histogram. So using something like this, you could imagine if rather than looking at both dimensions, we were just simply looking at the x dimension. So we wanted to get counts across, from -5 to 5 of how many points are in each, x value, and you're able to bin that data. So there's a couple of different ways of dealing with that, but BigViz is meant to really help you create these bins and process your data before you get it ready for these types of visualizations.
Okay.
Cool. And I see. So any other questions? Like, did that make it clear, Arindam?
Yes, I have one specific question probably, and I'll wait for the completion of the presentation, then I can ask for
Is it
that is
related
specific
to what we
big.
were just?
Yeah, this is related to the big fish. I was trying to do one thing and I came across one issue and I was trying to search some material around that.
Okay, what were you trying to do?
Actually, I was using this condense function, and if I have a one categorical variable, so what I understood that now when I'm doing this binning, I need to have mainly the numerical variables. So what if I have some values in no categorical variables? So can that be used in some other way?
If you have a categorical variable, it should like you could almost think of that as already binned. There may be some situations where you so I guess what I could think of is if you have very fine, fine grained categories. So if you have like a million data points and 10,000 categories that those data points are in, and the like you're right, because you're right that bin and condense it works. It's really meant to work with numerical data, and it's like for categorical data, I would say that um, it might make more sense to sort of using the situation I mentioned where maybe if you have like a million data points, 10,000 categories, so it might not make sense to display that on, you don't want like that dense a heat map. You really what I would think of is try to think of your categories as hierarchical and maybe try to zoom out in that way, because there's not really an automatic way that's coming to mind that you would really be able to bin it in a way that in like an automatic way, but it would be more like if if there's any way to kind of so if you're thinking of like you have countries and you want to sort of move up a level to continents or something like that. um, but you are right that it's meant to deal with numeric data, and there's not really an automatic way to uh, deal with categories.
Okay, that clarifies. Yeah.
Okay, and I think, oh, what did I do? I think I might have put it in my GitHub. There we go. So I think the test, and Andrew, I'll get to your question next. I saw that in the chat. Yeah, so here, let me just download this. Because I don't remember where I saved it my in my file. So here, let's just open. Let's get to downloads.
So would you be able to share the those homework from different students?
Yeah. So actually, so what I did was I ended up, rather than try for the last lecture, rather than trying to recreate the slides, I just created the essentially an R script that goes through the like what I was going through. So we'll be able to look at the different examples there. And I didn't add them yet, but I'll add like what other students have done as well, like a couple of sort of creative solutions to looking at the homework one, just to kind of give you guys an idea of what other people have done. Um, Getting back to Big Viz here, so and this is just a sample of the Pluto data that I'm reading in. So it's not the full data set, but it's still something that's pretty large. And here, this is sort of looking at a sample of a kind of a sample question. So this isn't one of the questions from the homework, but just looking at how is lot area changing with year of construction. So we have, if we're looking at what this data looks like, I ended up filtering this. So we're looking at data after 1850. We're looking at only larger lot areas, and we're not looking at sort of very large assessed totals. So just some filtering there, and then I'm just selecting this based on the variables that we're interested in. So we're looking at lot area and year built. And so when we have something like this, and if I just look at the head, so we have like a bunch of data points here for essentially every building in New York. And if we want to bin this, it's best to look at, kind of take a period and say like, rather like bin it by year. So in this case, we'll bin it by 5 years. So what we're doing here is we're binning it right here. So we're binning it by year built. And here, so we're choosing the length of the period that we want to bin it by. So we're binning it by 5 years. And what this Z argument does is it tells us, like, do we want to map the, do we want to look at one of the other variables binned by, do we want to look at one variable binned by another variable? So if I didn't include this Z variable, we would end up with something like essentially a histogram where we had several, let's say we were just looking at lot areas and I were simply binning by, an area amount. I would end up with a histogram of lot areas for all the buildings in New York, which is something that's useful if I'm looking for that. Like that's definitely a, giving me some information. But in this case, what we're looking at is, we're trying to find the relationship between two variables. So looking at how, looking at lot areas binned by 5-year periods. So that's what's happening in the condense function. And then I'm just doing all of that with p data. So I'm referencing the variables. And I mentioned this during the Big Viz video, but normally I discourage using autoplot. Like ggplot, it has a lot of, it does have the autoplot function, but normally I like having a bit more, like giving a bit more thought to what you're plotting. But that being said, Hadley Wickham created both BigViz and ggplot, so it's kind of tailor-made to create a data set that has a particular way of visualizing it. So autoplot does work pretty nicely with data worked with in BigViz. So if we autoplot this, you could see what we're looking at here. Or you could see that we're getting something here. So we're looking at 5-year periods. We have count that's coloring these points. So it's so we're getting some information about how many buildings were built in each 5-year period, and you could kind of get an idea of what the trend is. So kind of a general upward trend in lot area until we reach the 70s, and then we have this dip, and then for some reason a kind of large uptick here. So does it make sense to you guys what this is representing?
It does, yeah.
Cool.
One quick question, in that bin, no, is it possible to have another numerical variable, like if I would like to have number of floors along with the year of built, is it possible to have more than one numerical variable in bin?
It is, and this is so here, like one of the examples that I provided was this is using a different data set. So this is actually using a movie data set and showing that bins can be two-dimensional. So the way that you could see something like this looking is here we're looking at movies. So I'll bring in the movies data set and the way that we're doing this is we're essentially it's all happening in the condense function, and we're running and we're essentially looking at two bins. So rather than like here, you could almost think of this as we're looking at lot area and we're binning by year built. Here we're binning by two things. So we're binning by the length of the movie, and we're also binning by the rating of the movie. So what we do have in this, I'll just look at, so what we do have in this movies database is we have lengths. So we have like a bunch of movies, we have lengths of those movies and ratings. So ratings are there. And obviously like this is sort of meant to, this is actually coming from the Big Viz package, so it's meant to kind of illustrate what you could do with it. And it's looking at those two, so what we would, create by this, like you could think, let's, create a, let's say, so the way that you could think of something like this, this is, I think that should be, I don't know if it's just yeah, it was just taking a long time. So when we just use ggplot and geom-point, you could see that we're not getting good resolution at all. And something like this, it's I mean, you could see we're obviously having issues with outliers, but even outside of the outliers issue, where even if we cut off our data, we would still really have a screen of black, and because the points are there's just too many points. So this is one of those situations where what I was showing you before, where we had a lot of points, and you want to bin it into in this case a heat map. So when we bin this, essentially we have this condense function, and we have two bins. So we have bin by length, and here, what I did, rather than define the length of the size of the bin, I ended up having this number of bins, and BigViz has a helper function where it's letting you find the width based on the number of bins and the variable. So here we'll bin the data. Whoop. And then when I run ggplot, this geom raster, it's going to add the this is going to create a heat map. So we are still having problems with outliers. So this isn't the most useful here. But then there's also this helper function called peel, which automatically gets rid of outliers. So we end up with something like this. So does that make sense?
Yeah, it does.
Cool. Cool. And there is that Big Viz video that I posted, so that actually goes through this script. So a lot of what I was going through, it'll there's a couple more. I go into this in a bit more detail. So that'll also help out. So, yep. So, yeah, Andrew, let me go through homework one. So, what I ended up, and yeah, so the Pluto homework is due next week. So, if I think I might have to allow you to submit it again. Like, have you tried to submit again? Or I guess I'll like if we'll see what happens with Blackboard. I don't know if they'll block you from resubmitting it, but obviously I'll it was due this week, or it was due this week, so I'll let you resubmit it in that case. Yeah, unfortunately, I'm not hearing you. It's due this week. It's due on Sunday of this week. Yeah, and watch the so watch the video, see if there's any more information about Big Viz that you're able to take into it, and feel free to go over it um, and look at that. So then your next question about the about homework one, so basically what I did, rather than like I mentioned, rather than trying to like change this into slides, like I decided to just have a script that you guys would be able to look through um, and run yourself. So let's just close this here. So I'll go through these examples so that they're clearer, because we weren't able to look at a lot of a lot of the graphs before because they were getting cut off, and a couple of things that should have been clear weren't really showing up on the slides. So like this is looking at question one, where we're just looking at counts of we're just looking at counts by state. So this one was fairly straightforward. I think I mentioned on the last call that everyone ended up getting this one. So we're looking at counts per state, and then the main Yep, yeah. So Andrew, this is, and I think it'll be helpful just to show these. So I made sure that the links were public before they were showing up as private for some reason, but all the links should be working. I'll add this video as well, and you guys will be able to watch those. So I guess kind of to quickly go through what we sort of went through in the last meetup. For that first question, the main part of that first question was making sure it works in a tablet mode. So the real way to do that is just having this coordinate flip, and that lets you very easily kind of get a graph in the right orientation. And then what we ended up looking at was reordering the states, because this makes it easier to compare the different types of the different counts here. So if you're looking at Virginia versus Florida, for example, the order gives away the fact that Virginia has more companies than Florida. But if you had those two states further away, you wouldn't really be able to see that. So this gives you more information on that. And then for question two, we were diving into New York, and didn't really show up before when we were looking at the outliers. But here you'll be able to see this more clearly. So when we're looking at this, because we're looking at individual companies, we're more focused on kind of the range of number of employees. We're looking not just at kind of an aggregation. So one of the best go-tos for something like that is just adding geom point and looking at a scatter plot like this. And here you could see the problem that we're having with outliers. So by showing these, we're ending up with not that much information about what the ranges are for these industries. So yep, and actually, in terms of people who like what people used for this, most people used either box plots or some people used bar graphs. Bar graphs didn't really show the by nature they're showing one measure for each for each industry. So when we were looking at for the previous question, which was looking more at that type of data where there's one measure per industry, the bar chart makes sense because we're looking at we're able to see that one measure. And when we're looking at something like this, there are multiple companies within each industry. So a bar chart by its nature would have to abstract some of that information away. So you would have to show either the average, total employment, and when by showing that, you're kind of losing information about what's happening with the individual countries. So that's that's one of the things that some people lost points on, which is when you're looking at when you're looking at something like this, you need to see what that kind of you need to see more about the range there. And yeah, Andrew, you're right that box plots are another way to do that. So here, this is just how we were dealing with outliers. So you're getting more information about the distributions there. And here is what this would look like as a box plot. And if you if you think about it, like this is really giving us the same information that we have here. It's summarizing it a bit for visual clarity, but it's kind of giving you a summary of what the range is. And then similarly, you could mark the outliers on a box plot like this. And so that was, yep. And box plots could be used for like box plots, like people got full points for using them for questions 2 and 3. There are a couple of other ways that you could have done that. So these were some of the, I think I have to do this first. So there are other ways to show variance, but you need to kind of pre-calculate the ranges. So here we're kind of manual, like a box plot does this automatically. So it kind of gets our interquartile range. We have like the median, the interquartile range in the box, and then the whiskers showing, and then outliers. But the point ranges, you kind of have to do that manually. So with something like this, we're essentially setting our range here. So we have a y min and a y max. So here we have that point range. First, we're adding the geom point, which is looking at the median, and then we're adding that lower and upper. So we're ending up with something like this that's giving similar information to what we had in box plot. Yeah. And then another way that we were looking at was adding error bars to a bar chart. So yep, I'm posting. I'll post this code so that you guys could take a look at it, Andrew. So here, this is just another example where instead of using the point, we're using bars. And this is very similar to what we were showing there. And you could see it's you're pretty much just replacing point with bar and replacing point range with error bar. So we're looking at that. And then this is just making that look a bit more styled. And then for question 3, the it could have also been answered with box plots, but for this example, I ended up providing another example. So this is kind of our first take of what we're looking at. And here we're looking at revenue per employee. What was different there? I forget what I think I accidentally copied that twice. But then what we're looking at here is rather than using a box plot, another way that you could think of looking at this is by using the principle of small multiples. So when we're looking at this, like a box plot, it's, if you're looking at a scatter plot, you're getting, you're essentially looking at what the points are underneath these ranges. And a box plot, it's abstracting some of that, but it's giving you the interquartile range. So you're still getting information about the range, about, which is how wide or thin the box plot is. But this gives us even more information. So here you could see that we're actually getting some information about the shapes of these distributions. So the additional information that we get, like you could kind of see, where you could see where your outliers are. You could see kind of where, what kind of distribution is, what kind of distribution you're looking at. But you're also getting information like, is it bimodal? That's something that you can't get by just looking at the interquartile range and median. Things like how wide or narrow it is, that is another thing that you're able to get. But this is just giving us that much more information about the shape of the distributions. And he's not here. I think it was, I forget who it was who was asking the question about facet wraps. I think it might have been Dan, although I don't remember exactly. But so for this right here, we are using what's called facet wrap. And what facet wrap does is it's essentially taking one variable, and usually a categorical variable. Actually, I think only a categorical variable now that I'm thinking about it. And it's giving us essentially small multiples of what we're looking at. So here we're looking at geom density, and we're providing the small multiples based on industry. And because we're doing this by only one variable, the positioning of these don't really matter much. So it's alphabetical, but we could have a different ordering. I could, depending on what my layout is. I don't think it'll automatically do it, but there are ways where you're able to, if I'm doing this very, long and thin, I could have just two rows and a bunch of columns. So like facet wrap is best used when order doesn't matter. And so yesterday, the question was asked about when does it make sense to use facet grid versus facet wrap? And the facet grid makes more sense when, so here I kind of added a little note here where facet wrap makes sense because we're looking at one categorical ranking. And facet grid makes more sense if we want to convey more meaning with the positioning of the facets. And the two ways that I mentioned here is either if the variable that we're faceting by is ordinal or continuous, or if we're faceting by multiple variables. And so as an example of something like this, I ended up just adding two more two more columns here. So I'm kind of creating my own ordinal variables here. So we're looking at either large or small companies, and I'm just looking at the median. Like this is meant to be an example. There's nothing really special about what I chose as my cutoffs here. So we're looking at just employee div, whether it's a large or a small company, and we're looking at growth div, whether it's a high growth versus a low growth company. And what we could do is essentially get a version of this that is comparing these two variables. And in this case, we're faceting by two variables rather than one. So here what you could see is we're now using facet grid, and you can see it's using that like formula notation where we're looking at one variable by another variable. And when we run this now, oh, I swear this was working before. Oh, yes. I need to run those. And then, so now facet grid, we care more about the positioning of this because we're looking to to compare like how high growth and low growth is interacting with large and small companies, and where so here you could almost think that almost think of it as like a meta axis here where we have size of the company against the growth of the company. So it's not super interesting what we're getting here, but you could see how this is showing you a bit more information. So the positioning of these matter. So does anyone else have any questions? Cool. Cool. So I'll post this video as well, and I'll make sure that we don't run into the issues we were running into on Tuesday again. So we'll hopefully have whole lectures and or whole discussions, meetups, and we'll meet up again in 2 weeks. So good luck on the homeworks, and let me know if you have any more questions. Feel free to send me an email as you're working on homework 2. All right, talk to you guys later.